So we have time for one more integral. This is another one from 7.5. It looks like it's problem 29 from 7.5. So I'm going to look at that and go, well, what do I want to do with this one? And that, oh, that's not what I want to do. Undo. That is the appropriate question. And what I see is an ln of something. And since I know the derivative of ln, but the integral is sort of hard and there's no obvious u substitution here, I'm going to do integration by parts. And of course, integration by parts, u is going to be the ln of x plus square root x squared plus 1. And then db, excuse me, it's just going to be dx. So v then is obviously just x. And du, using the chain rule, I'm going to get 1 over x plus the square root of x squared plus 1 times the derivative of what's in there. That's 1 plus, we need the chain rule again for the derivative of square root x squared plus 1, so it's 1 plus 1 half x squared plus 1 to the negative 1 half. It's negative 1 half there, times 2x. So let's simplify that a little bit, dx. So that is 1 plus x over x squared plus 1 to the negative 1 half over x plus square root x squared plus 1 dx. And I'm going to simplify that even a little bit further. If I multiply top and bottom by the square root of x squared plus 1, then I'll get that negative exponent out of the way, right? So I get the square root of x squared plus 1 plus x over x times the square root x squared plus 1 plus x squared plus 1. So what does that leave me? That leaves me with uv, which is x x ln, which is x ln x plus square root x squared plus 1 minus the integral of v du. Now the integral of v du does not look that great, does it? I don't know. Let's try I'm going to try a trig substitution here because I've got all those x squareds there. I got square roots of that. And see if we can get something out of here. But I'm not even really certain what a trig substitution is. It's not a straightforward trig substitution. So let's just try a trig substitution here. So, of course, what would the substitution be? The substitution would be tangent theta, right? Then dx would equal secant squared theta d theta. And let's just focus on this integral. So let's just focus on this integral here. Yep. And we'll copy this. Copy and put it down here. Paste. Let's scroll down a little ways. paste it there. I want to paste it there. And the whole thing didn't paste, so we'll just write in what we need there. We need integral and x here. Okay, so now this is going to be tangent x, tangent squared x theta, or tangent theta, let's make that a theta, tangent squared theta plus 1 is secant squared theta, square root of that's going to be secant theta, plus tangent theta times secant squared theta, d theta, right? All over. What kind of mess do I have down here? I have tangent theta, secant theta, plus tangent squared theta plus 1 is secant squared theta, right? So that's the secant squared theta. Okay, so right off the bat, I see I can cancel the secant if that's at all helpful. Oh, look at what else I can do if I factor out that secant when I cancel a secant. Okay, so let's write this out. So this is going to be tangent theta times secant theta plus tangent theta times secant theta d theta. Now I cancel a secant, so I've got to cancel it from each term, and I get a tangent theta plus secant theta, and there is, that works. Look at that, because now I can cancel. Let's point this out. Now I can cancel that and that. So before I canceled one of those secants with one of those, right? Now I can cancel this and this. And I get, okay, a much more doable integral. Look at that. That's going to be, oh, let me bring it over here to the non-disappearing ink. That's going to be tangent theta, secant theta d theta. And we know what the integral of tangent theta secant theta is, right? That is just secant theta plus c. And now let's go back up and solve for that. So going back to our purple, looking at our triangle, theta is the angle whose tangent is x, so that's x over 1, and this is going to be square root 1 plus x squared. Secant is hypotenuse over adjacent, right? So secant theta is square root 1 plus x squared. And so this is going to be undo. This is going to be square root 1 plus x squared plus c. And that's now, so that's what I just have for that integral. So let's go back to what we originally had. Let me copy this. Copy. And go back down. Paste. No, not there. We'll paste it there. So that's going to be, this answer then is going to be x ln of x plus square root of x squared plus 1 plus square root 1 plus x squared plus c. And there I have it. So the fact that I actually ended up with something pretty simple as my integral there, right there, The fact that I ended up with something pretty simple there makes me think I might have been able to simplify it beforehand, but we got it. We're done. Yay. Bye.